morning, good afternoon, good evening to everyone. I'm Kenny Law, member of ASP Astronomical Society of Penang. Recently, I have DIY made myself a mini observatory. So in this session, I would like to share with everyone how I make this mini observatory and how it can benefit or help everyone to have your own mini observatory as well. Okay, so let me share my slide. So today's topic is DIY your mini astronomical observatory at home. So the key here is mini and at home. Okay. This is my observatory, Canelo Observatory. It was completed last year, 8th of October, and the opening ceremony just on the last Sunday. I have two setup. One is for planetary and one is for deep sky. And this is the cover of the observatory. Okay. So here are some info about the observatory. The left side is my logo. The location is in Bayan Lepas, Penang, which is quite a very light polluted area in Penang, Malaysia. And the observatory size is pretty small. The length is just 122 cm. The width is only 112 cm. The height is 244 cm. And the cover size is 102 cm. The width is 53 cm. The height is 165 cm. So basically, it's a very mini observatory. And even though it's mini, I managed to capture some deep sky objects. Here are some of the deep sky objects I have captured. Okay. Move on. There are some more deep sky objects. Okay. Also all captured by this observatory. And moon as well. Okay. On the left side is the mineral moon that I try to process. And planet as well. This is also a moon occultation event that I captured, which the stars Kappa Capricorni, you can see on this dot here, is going behind the moon at early this year, 5th of January. Okay, there it just go off, right? So let me play back again. There you can see the stars in a while, then it is go off. Yeah, so this is one of the event I managed to capture. Okay, so come to the reason one of why I make this DIY this observatory, and I believe many people are facing the similar problem as me. Okay, so I put it as problem statement here. The first thing is I believe all the astronomy enthusiasts, astronomy lovers, they like to do more astronomy. They like to spend their time to look at the stars, take photographs of the stars, or even read up about astronomy, right? So here, what we are talking about is taking photos of the stars or looking at the stars. So observations using your telescope and so on. So basically, if a lot of time we wanted to do more astronomy, but we always have this Malaysia Hokkien situation, say boing, which means that you're busy with your life, your work life, your family life, whatever. You have other commitments with family that you need to do this and this for the kids and all those, right? So, and also a lot of time we have this situation like, okay, walao, you just set up the scope outside and it is now cloudy. Okay, so in Malaysia, especially in Malaysia, the weather is very unpredictable. A lot of time we just set it up and it just go cloudy. Okay, so same thing is sometimes also if you want to, especially those who are taking photographs, astrophotography, you will need to polar align your scope. You need to set up more gears or more equipments onto your scope. So that takes time, and a lot of time by the time you set up and you realize the sky condition is not at best situation anymore. Okay, so of course the very basic answer to this, yeah, if you want to resolve this I believe a lot of people will know that you need to build an observatory. But then the situation comes like, okay, are you going to buy a new house just or buy a new land that have big enough space to build observatory, like the roll-off roof or a dome styles observatory and so on, right? So the situation is like my case. If you can see, the picture on the right side is actually the top view of my house, and you can see that I have a very small garden area, okay, which is the dotted red, and I can choose, to put it in the middle here, which actually block my entrance, then or I have to squeeze it to this small area, which is about 5 feet to 5 feet. So I believe a lot of people also having this same situation, like you don't have enough place, right? So how to make it a mini one, right? So of course you need to look for a mini one, and a lot of time, also another situation like, okay, how do you fork out the budget and all those things, right? So then another way is to do a cover type observatory. Okay, so like what I have here is a cover type observatory. So I'm going to share more on how to do it. Okay, so the idea comes like this. For cover type observatory, we need to consider quite a few things. Okay, so one of consideration is it must be operate by one person, must be able to operate by one person. Okay, so the reason is because as you observe until midnight, how are you going to get your family members or whoever to help you to open or close your cover if it's big and heavy, right? So it has to be lightweight in this case. Okay, another one is it must be ready to photograph or observation in 5 minutes, meaning you want it to be like, oh, I see the sky clear now, is good in the sky now, right? So I just want to open the cover and right away press a button on the power and I can just use it immediately. And all the setups are there, so especially the mount, tripod and scope are all permanently inside, and all the accessories are there so that you can basically start within 5 minutes. Then you won't miss the chance of maximizing the uh, time to take photographs. Okay, same thing, close cover also we want it to be 5 minutes. And the other one is, uh, you want to control the temperature and humidity inside the observatory, because as the observatory is a small cover now, sun impact and the heat and the humidity impact will be very high compared to those roll-off roof situation, right? So you need something to control. If possible, my case, I'm using IoT or Wi-Fi controllers to control it. Okay, so if possible, you can try this. This is quite easy one and very hassle free. Okay, the next one is you want to make sure the environment is not able to have fungus or mold formation. So later I will share how you can do this. Okay, so the bottom pictures are my current observatory setup with the mount all permanently inside. Okay, as I shared earlier in the earlier picture, you can see I have two setup. So in that case, I actually don't put my telescope inside because at any time I could just use one of the setup. So I need to swap. The setup time will be faster if I just need to take one set of scope there and fix it on, rather than remove one and take again and put again. Okay, so this is the idea that I have. More into details on how to create, how to DIY this scope. Basically, if you have something like a German equatorial mount, or you have some probably some a bit heavy type of mount that maybe say over 7 kg or 7 kg or 10 kg, so you may want to build a pier to get things stable, or you can still use your tripod. Actually, there's no limitation to it. It's just that in my case I use a pier, so I actually get a machine shop to machine the three legs. Okay, so as you can see, the way I designed the three leg is the north leg is actually longer. That is because all the GEM mount, in fact, my GEM mount, yeah, the center of the gravity is actually not in the middle of the pier, but is towards the north. So that's why I have the slightly longer pier, so that actually the circle of the floor is kind of exactly in the middle. So that's just an idea to kind of make things more nicer. Okay, and I use mount steel for pier, and I paint it well so that it doesn't get any rusty and so on. Okay, so I also machine the aluminum adapter to the mount, which means when this adapter fit into the pier tube, that's where on top of it I can put the mount to fit in. Okay. Next thing is, as you put it on, right? So as you get the setup, you need to test it up. Like this case, you want to make sure that you find a good position for your mount. Okay, so because you need to arrange the mount to be north, pointing north, such as it's polar aligned, right? So you need to place it well in a place where, and then what you want to do is you want to swing it around, swing your scope around, and estimate the distance from it. Like if anything nearby, like my case, the wall, the neighbor wall, my house and my neighbor's house wall is actually nearby. So I have to do this measurement to make sure that the scope doesn't hit. And the more tricky one is you need to also roughly estimate for your future equipments. Like my case, after I have this Celestron C8, I do plan to buy another longer tube refractor. So I actually estimate for it such that when it swing, it doesn't go and it doesn't actually hit the wall. Okay, so these are some minor things that you need to work out. Then you need to put how to say, marking on the floor so that you know that is exactly where you want to place your scope. Okay, and you need to measure whether is it exiting your 5 feet case. So in like my case, I have to make sure that it is less, it is within 5 feet, or else then when my car comes into the car porch, then it will hit the tripod lah. Okay, so for my case, I want to make it a cover type, and plus I want to make it an observatory type. So how to say this is because why there are companies making covers for people, and they call it telescope cover. They don't call it observatory, and I want to make it with a lot of things, such as actually with that is actually an observatory. Why? Because I'm putting in all the other equipments to make it like what an observatory has, except the only one thing that is not a normal thing, that is the human cannot go in. That's all, right? So that is the only difference. But to me, with all the equipments, there is an observatory. Okay, so how I can have a place to put all the things is I create this table. Okay, and I make some kind of support here. It's a L angle metal plates. Okay, so when I screw it to the pier, and then I put a kind of, not say plywood. This is a compressed wood. Okay, so I put the compressed wood into the pier. Okay, with that, then I can have a table. Okay, so of course, a few things that you need to consider on this table is that the length of your scope. Okay, and how can you easily take the cover out and in, with considering with your scope is there, and if this is long or short, so the table has to measure according to that measurement, and give some leeway to that, so that you can carry out the cover without hitting your scope. Okay. Next is pier leg insulation. So because of our weather, this pier leg is actually exposed to the sunlight. Okay, so we want to prevent sunlight radiated in, the heat radiated into the inside of the observatory, then uh, I came out with this idea that have styrofoam cover the pier leg, and then I have the aluminum insulation sheet cover the pier leg. Okay, so with that, then the whole pier leg is actually covered and protect from heat. Okay? And this is how the waterproof cover comes in. Okay, so the design is that I create an aluminum frame. Okay, don't try to make the frame very, like, how to say, very firm, that you can't actually bend it or can't actually turn it, because eventually when you move it up and down, you will actually tend to bend it a little bit here and there. But if you make a very firm one, even when you bend it, it will maybe get into a firm shape and causing it to be not in the proper, how to say, proper rectangle shape. Okay, so I actually use quite thin aluminum here, such that if you actually push it, you will see that it can shake a little bit. Yeah, but eventually with that, it helps me in placing it into the how to say, onto the table, because the table is in a fixed shape rectangle. So when I put it on, I my hand may not be perfectly putting in into that rectangle fit in nicely, because consider you have to carry this big thing up and down, right? So then as you put it in, it may be out a little bit, but because of it's so flexible, you can push it a little bit and it just fit in. So this actually helps a lot lah. Okay, so and besides that, with a thin aluminum frame, is very light. So with this way, then it will become a lightweight for you to carry by one person. Okay. So for insulation, I use this aluminum thermal insulation sheet, the one that here in a roll. Okay, you can see in the middle bottom picture. Okay, it's a roll that you can buy online, and inside I add on styrofoam sheet. Okay, so you just glue it, because this aluminum thermal insulation sheet, the inside of it is like a double-sided tape. Okay, so as I glue it onto the frame, like this picture here, middle bottom. Okay, I glue it onto the frame. Actually I remove the double-sided kind of protection here, the film here, and then I can glue the styrofoam into it. Then this way it will hold the styrofoam in shape. Okay. So once I cover the whole frame with the aluminum thermal insulation sheet, then I use this flex tape. Is a waterproof flex tape. Is also aluminum shining surface outside. I just glue at the corner here, and it will just put everything into the shape lah. Okay. So this is how you can make the cover. Okay, and here I have two video to demo how you one person can open and close the cover. Okay, so the right side is I'm taking up the cover from the observatory. So it looks big. Yeah, the cover is like bigger than me. Okay, but it seems I'm able to remove it very easily. Okay, it is because it's very lightweight. Okay, yeah. Then on the right side video, you can see that I'm putting it back. Okay. So I have to take it carefully because it's big. If winds come, it will, blow it, shake it. So I have to careful. Yeah. So the tricky part is to fitting it back in. See, yeah. So it may not be perfect at the first place. I need to move around. You see, I move around a little bit, then it will fit in. So try to make it flexible, then it will be able to fit in very well. Okay. Okay, so before I move to this, yeah, one more thing I want to I want to bring up. Yep. Um, okay, so as you can see, this is one of the lessons learned that after I created the first version. Okay, um, as you can see, it's a rectangle. The cover is a rectangle, and the top is basically with this way. The top is flat. So when it rain, water will actually stay on it. And if you are going to observe it right after rain, then when you take the cover up, the water will actually drop on you. Okay, okay. So later phase, I actually put in some kind of styrofoam bar to make it like a triangle up, so that the top here it becomes like our roof, our house roof. Okay, our house roof that is not flat anymore, but is triangle up in that shape. Okay, so this is something that you can take note, that it will help you. Okay, so next thing is, yeah, to complete it as an observatory, yeah, you need the rest of the things, yeah. Especially in the situation I explained just now, we want to be able to quickly power on the of telescopes and use it, right? So here I have actually the power supply with Wi-Fi IoT switch, okay, which I actually can control by voice, or I can with a button press here, then I can just on everything, and everything is connected together one. So then in that way, it will be very fast. Okay, so the next one is that to control the humidity inside, very basic thing, I just buy a dehumidifier and put it inside. But because the dehumidifier humidity control is not very perfect, so I actually bought a separate IoT Wi-Fi switch with a temperature humidity sensor. Like, if you can see the picture on the right side is actually a on-off Wi-Fi humidity control switch. Okay, so with that I actually connect to turn on and off this dehumidifier when it's needed. Okay, so today I control it to be always below 60%. Okay, of course cannot be perfect. Why? Because the probably I hop a little bit to item number 10 here. Why is because a lot of time after astrophotography session, we observe through the whole night, right? Sometimes, and it becomes so humid, yeah, especially in the morning, early morning, right? Then I take all my scope to inside my house, and I just close the cover, right? So at the moment of closing the cover, humidity is definitely above 70%. Okay, so this is that high moment that uh, where I install UV light inside the observatory cover, and as I close the cover, the Wi-Fi switch will detect and say humidity is above 70%. Turn on the UV light. So this way it will prevent fungus and mold from growing. At the same time, the dehumidifier also kick in, and it will slowly dehumidifying the air. With that, usually it takes about 1+ hour to bring it down to about 60%. Okay, because actually usually after observation is 80 something percent. Okay, yeah. So separately also I have the temperature control. I have a liquid cooling system to actually cool down the air inside the observatory. Okay. I also use the IoT Wi-Fi switch. You see I have another switch here. Okay, so actually to control the temperature. So when the temperature is getting high up in the afternoon, then the liquid cooling system will kick in and bring down the temperature inside the box, inside the cover. Okay. And this is how the basic control is today. For temperature control, it controls to be, if the temperature goes up more than 33 degrees Celsius, the Peltier liquid cooling system will kick in and start to cool down the environment until it is lower than 31, then it will stop. Okay. And for humidity control is when it's more than 58%, it will kick in and dehumidifying the whole place, the whole cover inside. Okay, so when it's below 56, then it will stop. Okay, so this is my current setup. And with that, you can actually see that, okay, so this is another something that I have inside my observatory is a monitoring system I built with a small Raspberry Pi with temperature sensor, humidity sensor as well. So I put one sensor inside the observatory on the mount, on top of the mount, and then the other sensor is outside of the observatory, just below the table. Okay, so you can see that the first bar chart on top is actually inside temperature. So it's showing that the inside temperature at midnight is quite cool. Okay, 29, 28, 30, around there. Okay, so it will slowly get heat up at 1 p.m. and you can see it's hitting about 34 at 3 p.m. and 4 p.m. Okay, so then it's slowly cooling down. And correlating to that, the outside temperature is showing that is 27, 28, 29 in the midnight. And then it goes up to 37, 39, 42 in the afternoon. Okay, so you can see the temperature is correlating to that. Yeah. And the inside RH is always keep within like 50, 60, 57, 58, 60, around there. Of course, sometimes it will go even lower. The reason is because our sun is very hot and that whole environment is very dry at that point. Then it actually helps to bring down even further. Okay, but of course the temperature will be higher. Okay, so the outside humidity you can see in the midnight is very high, and it becomes very low in the afternoon. Okay, and this is my liquid cooling system that I have this this is one this, actually this is my first version of liquid cooling system. So I use 6 Peltier and 4 cooling coils, a radiator fan, and two 12-volt 20 amp power supply. So okay, I will show more on the Peltier side. This is the Peltier water cooling block. Okay, so I have 3 water cooling block with 6 Peltier inside here, and the liquid cooling goes up to from through the table to the top. Okay, so when it reaches the top, this is the 2 cooling coil that I have to cool the environment. Okay, so another view, another angle from the top that you can see the cooling coil and the fan. Okay, so this is how it's being constructed. Okay, and then I have another 2 cooling coil here at the bottom of the table. This is to cool down the hot water because Peltier will have one cold side and one hot side. So for the hot side, I also have liquid cooling to go out to a cooling coil. Then I use fan to cool it down. Okay. On the right hand top, you can see 2 power supply. This one, each of these is 12-volt 20 amp and is supplied to 3 Peltier, each supplying to 3 Peltier. So with this whole system, I'm able to maintain the temperature to below 37. Okay. So my suggestion is if you want to be more effective, you can try 8 Peltier and 6 cooling coils. Okay. Of course, at the same time, you need to bump up your power supply as well. Okay. Mm. So this is how the Peltier and cooling block construction is. Okay, so this is the small Peltier chip that I use. Is a TEC1 12706. Okay, Peltier, and I have 3 of them in one side, like this. Okay, so 3 in one side, 3 in another side. So meaning the middle is a water cooling block for cold water. Okay, and the other 2 at the side, one on top and one below, is water cooling block for the hot water. Okay. So with this, then from this angle, you can see that all the 6 nozzle of the water are there. Okay, and then with the water cooling block, on top of it, I add in heatsink. Okay, so like this. This is a heatsink to even further cool down the water cooling block. Although this water will be going to the water cooling coil, okay, with the fans there. Just now I show, right. Still to further cool it down, I have heatsink, and then I also add on fans, okay. And I want to prevent this the cold water cooling block lost the coldness. So I put in styrofoam to block everything. Okay, from the, especially because this is going to be outside our house, especially in the afternoon hot sun, hot environment, the cold water block will be like, not so cold anymore, right? So and then I use this Toyota coolant liquid to actually as the medium for water cooling, rather than using the normal water cooling, plain water. Yeah. So in a summary, with these with these three features, first feature is a lightweight, waterproof, heat insulated cover. Second feature is an IoT control Peltier liquid cooling system. And third feature is IoT control dehumidifier system. Okay, so with these three features, it will help you to keep your telescope outside of your house with no worry of heat and humidity. Okay, of course, it does cost some, but not a lot. Consider this whole thing just all adds up probably is about 800 to 1.4K, depending on the size of your telescope, your observatory cover, and size of your Peltier, if you have more Peltiers or you have more cooling coils, things like that. So it depends on that. Yeah. Uh, or this cost does not include your telescope. Okay, so this is purely talking about the observatory making. Okay. uh, I'm not sure, is there any questions by anyone? Cynthia, do you see any questions by anyone? I guess no. Okay. uh, so moving next, some more features on the observatory. So the way I do it is that I don't want to dig my ground or knock my wall or anything, because with that I'm not able to move around that much. If one day I need to move house, right, or one day I find a better location, like because right now I'm in Bayang Lepas, is bottle egg situation practically. I don't see a lot of stars, right? So if I happen to move to other place, then I can bring it with me very easily, right? So if you look at it, this is very simple pier leg that it just touch the ground. It won't screw into the ground. And same thing also, the middle of the pier is actually touching the ground. Okay, but it just touch only. It doesn't. I don't dig in anything. I don't screw anything on it. Okay, and this is the two interchangeable system I have. Okay, the left is for deep sky, the right is for planetary. And this may be another thing that you want to consider. Okay, so for some, if you plan to put your optics into the telescope, together into the telescope mounting inside the observatory, then you may want to consider a dust cover. Okay, so I have this motorized dust cover, which I plan to eventually put my C8 inside permanently. So this is how the motorized dust cover work. Okay, so as I turn on the switch, just now I mentioned that switch, right? One button click, then this dust cover will just open up by itself. I have pre-configured it to go to, to open up to this angle. Okay, and something else you need to also look at is uh, clean cable management. this is very important because you know a lot of time, especially those photographers, we have camera, we have CCDs, we have guide camera, we have so many things that you need wires, right? And if you don't manage it well, a lot of time is going to hook on your scope, and then out of sudden you realize things can go fall down or whatever, break, right? So I combine all 4 cables into one cable sleeve, and I try to make sure that these 4 cables are the soft type, so that it doesn't actually drag your scope and is very lightweight. Okay, so also similarly, I thought of a way to use only one USB to switch in between the planetary setup and the deep sky setup. So in that way, um, actually I don't need to put in more cables. Okay, so for like planetary setup, okay, how to say this is that I actually use, actually this USB cable is a USB extension cable, which means one side is female, one side is male, and then at the male side I custom made a cable that can go to the computer or can go to the telescope controller. Okay, so then it's two different USB head. Okay, so in that way, then I just need one cable, and with that, then it will be saving your cable weight. Okay, so this is something that you can think about. Also, something else that you can think about is to have a kind of, if possible, yeah, as small as possible, a kind of a power distribution box, where because we need quite a few things, right? 12 volt usually is for your telescope, and you need to run some other things, like my case, I'm running Raspberry Pi, so I need a 5 volt supply, and I need two because I have two Raspberry Pi, one at the bottom, the observatory side, one at the telescope side, and also separately I have what do you call this uh, JMI autofocus. Okay, so for JMI autofocus, I need a power supply as well, and that is a 9.4 volt. So then I have a special 9.4 volt here, and yeah, so with this, actually the same one button, when I press, everything just turn on by itself, and including my Raspberry Pi and the LCD monitor inside my observatory. Okay, so yeah, just a little bit on the planetary setup, a few things. So the JMI autofocus is here, my CCD is here, telescope, yeah, and I have a dual heater controller. Okay, and a dual heater for this scope, yeah, and the dust cover, and a Telluride focus finder. Okay, so for the mount, I was going through that time. I think this was like probably 7 years ago, or yeah, around there, maybe 6 7 years ago. Yeah, um, I bought this mount because of it has internal cabling to handle the two motor drive, so that you don't see the cable outside of the motor drive. So in fact, for me to connect to the mount, I only have one hand controller cable here and one power supply control here, and that's all. This cable is the one that I connect up to the scope one. Okay, so I always have it hooked over the mount when I'm not using it. Okay, and this is the setup for my deep sky. Okay, so as you can see, I have all the cables separated by each scope. Okay, so for this scope, I have a ZWO ASI 533 MC Pro cool color camera. This one I just use a cable connect up, and then I can just use already. So all these are the cable for the dual heater here, and because it's too long, the cable, I just wrap it up here so that it doesn't come down and drag down to the bottom. So these are some of the things that you need to uh, make a clean cable management. Okay, so for the main scope for deep sky, I use a ASCA FRA 600, And if you can see here, there are some cables here. I have a Raspberry Pi computer here, and all the USBs are connected here, so that the camera USB, CCD USB, the guide scope guide camera USB all goes in here. Then all the cables are here, and I only have that few cables down. Then very clean in that way. I have not faced any problem on the cable hook on each other. Okay, so this is all I have at the moment. Of course, before I move to Q&A session, um, I would like to ask a question to everyone. Okay, so after this sharing, do you see a road to do more astrophotography or do more astronomy? If yes, then congratulations. You maybe understand what I'm trying to explain. But if no, don't worry. You can always talk to me. You can reach out to ASP, Astronomical Society of Penang. Then that's where you can find me, and I can help you. We can discuss in more detail, because this is a very short session. There are details on how you can make the frame of the cover, how you can make the pier, or so on. And there are also how you can make the tables and how you do the IoT controls. Those are very important to make sure that you have a good temperature and humidity in your observatory. Okay, so eventually I hope everyone can do more hands-on astronomy, and this is not a difficult thing. I think our chairman always say, our chairman Dr. Chong always say, just do it. Doing it is fun. Okay, yeah. So let's see if there is any question. Jin Tiong, do you know, is there any question? Oh, okay, there's no question. Okay. So if there's no question, maybe I just add on a little bit to a few things. Okay. Um, so let me flip back a little bit. I understand this topic is a bit very, how to say, very specific into building your observatory. Okay. So today you may say, if you look at this setup, you may say that, okay, so I have a Celestron C8, I have a Mao GM like this. So that's why I make a observatory. But actually not necessary. If you have a small telescope, even though a small portable telescope that you think that, okay, you want it to be outside your house, uh, so that you can save your setup for polar alignment and all those, then you can also do it. And it's not a necessary thing that for you to build a table or build a pier. You can put your tripod outside, just need to make the cover fatter, right? And probably it's not this long as well. You can probably shorten it because it depends on your scope situation, right? Your scope length, right? So you can probably shorten this and make it fatter. Maybe let me see. This, okay, this, yeah, this slide itself. Okay, so you can see that the length at the and the width of the cover is this small, right? So if you are putting your tripod on the floor, then you can just make this fatter, and you can actually still cover on the whole tripod. Okay, yeah. uh, then this way you can still have your observatory and no need to build the pier and table. Okay, okay, so I think we have okay. So there's a question from Fabian Wiley Kong. He's asking, where do I buy my Celestron telescope? Okay, so my Celestron telescope is half lah. Bought the C8 very long ago. I think it's like 20 years ago. I bought the C8 from overseas. The I think from overseas, yeah, overseas second-hand seller. Okay, so the Celestron CGX is a mount that I just bought about I think 7 years, 6 7 years ago. Okay, from KL Celestron distributor. Okay, um, I'm I I think the shop I'm not too sure the shop is still there, but forgot the shop name. It was run by Su Fen. So I forgot the shop name. I think is what's the name already? I think if you Google the Celestron, you probably can find it. Maybe in a while I will let me just find out the name. I also forgot about the name. Yeah. Okay. Uh, so let's next question is from Dr. Chong is saying wonderful observatory. Thanks, Dr. Chong. What is your astrophotography plans for planetaries and deep skies object? Okay. So uh okay, all right. So I think Dr. Chong's question is on what is my plan for planetary and deep sky objects. Of course, I do have the what do you call? I do have a list of folders that I plan. I list down in my cloud hard disk what items that I wanted to take. Of course, a lot of time it depends on the sky condition. Okay, because sometimes the object you want to take is covered by clouds. Okay, so you got to move to the next object. So, but how I do it is that I have a plan of objects by month. So then if one object is being blocked, I can always move to the next object. So that will be easier. But then I think I won't go into detail a lot on how to take astrophotograph or what is my astrophotography workflow. I will reserve those for next round. Okay, yeah. Right now this session is more on DIY of mini observatory and hoping that I can share more information and help more people to build their mini observatory. And it's quite cheap, right? As I mentioned, it's about 800 to 1.4K. So it's quite cheap and is going to give you a lot of conveniences. So I can give some example on the convenience that I have. So actually, some of you that have been observing with me together in the society and so on, right? Or maybe close friends, astro friends with me, right? You know that uh, I every year maybe only have a few astrophotographs, not many, right, throughout the years for like 10 plus years. And one of the things set me back is all because sometimes for me to set up all these things, it takes like some time already. And a lot of time after setup, I just have to wait until the sky clear again. Then only I can take astrophotographs. So throughout the whole night, probably I don't get one or I get one, things like that. So, but with this observatory established since end of last year, okay, in fact, I was testing it since mid of last year. Okay, so I think my friends are seeing me sending out pictures and pictures more and more uh, for these few months. So it is quite a surprising thing to me also that I managed to take so many pictures. Of course, a lot of them are still not so good because a lot of them are actually test pictures. Okay, so hopefully going forward I can take more real serious pictures. Okay, and the other thing is also that um, nowadays a lot of time um, it happens to me like this right? I settle all my stuff. I going to bed, going to sleep, maybe midnight around 12 o'clock or 1 o'clock, right? I go to sleep. So it happens like, okay, this is a weekend, Saturday night and so on. So I just check my handphone and see, because I have a all sky camera on top of my house roof. So I check my handphone to look at my all sky camera. I see the pictures and then realize, oh, the sky is not bad. Okay, let's so I just take a walk out to my house and see again, confirm the sky is good. Then I can immediately just remove the cover and put my scope on. It just take me about a few minutes. Then I can set up everything and press the button on. Then I can take pictures already. So that's why it helps me to take a lot of pictures. Even like the last few days, I think 2 days ago, about 9 to 10 o'clock, nine something, yeah. So the sky was clear for about 1 hour after my dinner. immediately I go out, I have 1 hour and I managed to still capture quite some pictures. Okay, so eventually all these pictures piled up and I can have a few days picture and compile into one pictures. Right? So that's how I do it. And I find that it's really helpful. Okay. Okay. Thanks to William Chin, the company name, yeah, that I bought my Celestron CGX for Fabian Y Lee Kong. Okay, the answer is Star Optics. Okay, so I bought it from them, and it was quite many years ago. I'm not sure if they still sell CGX or yeah this telescope. Yeah. Okay. Next comment come from Jared Chong. Great work with your setup. How do you simplify the polar alignment steps? Oh, okay. So, Jared, a very good questions. And basically, right. So this is very similar to how we do polar alignment, and I just need to do it one time. Until today, I did a few rounds. Of course, I was fine tuning. Okay, so the reason few weeks I have not been doing polar alignment anymore. Okay, so not say few weeks, sorry, I should say the recent few months. I have not been doing for polar alignment anymore. So what I did, the basic one is earlier on I showed in this slide, right? I put my mount and my pier on the place that I want, and I start swinging around. The Before I do the swinging, I actually do the I use a compass to make sure that the north leg is pointing north, and my mount can be adjust accordingly to north. Okay, so that is a very rough with compass only. Okay, so with this way, then I do this swinging around to make sure the space up. Okay, so with that, then once I have the good clear night, I have can see quite some stars. I will do polar alignment by using my Celestron to do polar alignment. Celestron have a hand controller that have steps for you to go through to do polar alignment. So I use that step, I go through, and then I do adjustment here. If you can see the adjustment on the mount here, right? So I just adjust it. Then this one is a knob for azimuth. Uh, then this is the knob for altitude. Okay, so I adjust these two, settle, and of course I need to adjust the altitude height here. Okay, this one is to loosen it only, sorry. This one is the adjust one. So after I adjust, settle, then I just keep it. And I did a few rounds of fine tuning with using PhD, going through taking the snapshot using the PhD to do alignment. Then once I did it, then now I just always keep it. And with that, in fact, every time I power up the scope, I point to anything, it will always point to the same place. Okay, so that's how it is. Yeah. William Chin asking how is the sky above your observatory now? Okay, so okay, let me just show the sky above my observatory now. Okay, so I have a all sky camera running on top of my house roof. Okay, so this is the Canelo 222-degree waterproof all sky camera, and the sky is very bad, William. Okay, so it's super cloudy. I think this is moon. Okay, so it's even moon is even covered by clouds and only a small dot there. Okay, so this is my neighbor's house, which is a little bit taller than mine. Okay, and the small hill opposite my house, on the southwest side. Okay, so this is the trees there. Okay, and the whole all sky is in a circle. Yeah, so this is a real time image of the all sky, 9:25, 19 p.m. Today, 12 March. Okay, and inside my all sky camera, I have a temperature sensor and also humidity sensor. So the temperature is 37, the environment temperature. The processor, Raspberry Pi processor temperature is 51 degrees Celsius. RH on the environment is 59%. Okay, yeah. So this is the, I think that's all I have. Is there any more question? No more. So I guess if okay, maybe let me just see, since we have a few more minutes left, right? Let me just, probably I speak too fast. Okay, so another thing is that, another thing is, yeah, I think I did not point out exactly the UV light location. Maybe I just flip back to, yep, here. Okay, so this is the cover from the bottom for the inside view lah, inside view of the cover. So you see the the styrofoam there has got one line, right? One line and one line. Okay, so actually I glue my UV light here. Okay, I glue the UV light. It's a LED UV light, and I have a small connector here. The connector is like our, those that you can buy online, the handphone USB magnetic connector. Okay, so it has a magnetic interface. Okay, is where I came out with this idea. I'm quite happy with it lah. The idea is that because I take up and down of the cover, I cannot take halfway and then I have another hand go and which it has to be the third hand where it cannot happen. Okay, I don't have two hands, right? So I need another hand to remove the connection, right? That is very difficult. So then after some thought, then I make use of these handphone magnetic connectors. Then as I remove the cover, the connector will just go off by itself. And when I plug in, put back the cover, the observatory cover, when I put it back, at the moment is near to the closing part, then the magnetic will actually click on it and contact well. So in that case, then everything is just handled by itself lah. Then the UV light will kick in when the humidity is higher. Yeah. So this is one of the things that you can also consider. Okay. Um, what else? Okay. Oh, okay. So one more thing, just for take note, the Peltier is a very sensitive device, module. Okay. So if you happen to buy one and you start to pump in 12 volt and maybe whatever ampere, right? Okay, so then it start to heat up and one side will be hot, one side will be cold, right? If you don't have heatsink around it, don't test for very long. Try to test less than 5 seconds. Okay, you just want to see whether which phase is the hot and which phase is the cold. Then you know where to put in this to stick it on to the water block, right? So, but then don't open too long without hissing or without anything, because it will just burn by itself. Okay, I have burned quite a few last time. Yeah. Okay, so this is a few important things that you want to take note lah. Okay. Anything else? I think probably that's all. Yeah. So if you, okay, so next thing, maybe I should just mention also one more thing is this. Yeah. Uh, I'm in the planning. Okay, I'm in the planning to design another small, how to say, small device that can use for this kind of purpose. The device will include all sky camera, UV light, dehumidifier, cooling system, and IoT controls all into one kind of box, where um, one part of the box you need to keep inside your cover of the observatory, and the other part you just leave it outside. It's okay. So with that way, then it is going to be a very easy to handle module, where you can just bring around like a probably like a small luggage bag like a small luggage bag, so you bring it out to your house. Then there's only one 240-volt AC power cable out, and then you plug into your power cable, your power supply, your house power supply, and you make one the cover, okay, for the observatory. You just cover on and done. So you have your observatory running already, and you will not need to worry about the humidity and rain and temperature as well. Okay, so in this design, later on, after I have all the design done, and when I start kick off some DIY, I probably will take more pictures, and I can do another sharing specific to whoever interested on this. Then yeah, you can follow that way and build your own one. Okay, yeah. Oh, there's one more question. Is it, if only telescope is dismantled after astro view, will the polar alignment be still intact when telescope is mounted again on another day? Yes. So Jared, okay, so this is a very good question again. Yeah. So it's like this. When most of the go-to telescope today, we have this feature, home position. Okay, so what you do is when you mount it, when you let's say after use, you dismantle everything, dismantle the optical telescope tube, and then when you place it back, you worry that it's not in the home position, right? So what you do is you put it back, everything, then you use a compass to make sure that it's in home position. That's one way for some of the telescope. And of course, there are some telescope like my Celestron CGX. There's an advantage. It has a home sensor. Okay, so as I power on, it will actually you can actually by a click of button, it will actually, in fact, it's the first button that you need to click. Okay, as it power on, it will ask you to do that. So when you click that button, it will actually go to the home position by itself, and it's always accurate. Okay, so actually for my case, I don't use that. The reason is, sorry, I should say I don't use that button press, but I use remote control. So because I designed my observatory for remote control purpose, so I actually use my laptop. I connect it when I power on. I connect it there, and on my remote control there, the screen, I have a button to click align. So when I click align, it will actually go to the home position, and always from there onwards, everything is accurate. Yeah. So this is one thing that you need to make sure the home position is correct. Yeah. You can use a compass for those scope that don't have a home sensor. Okay. So I think that's all for the session, I believe. Yeah. So thank you everyone for listening to this session. I hope that this benefits you. And if you have any question, you can go through ASP to look for me, or if you know me, you can just ping me. Okay. All right. Have a good night. Bye.